So now in the first application of the Coriolis force, we want to model the so-called surface Ekman. So now forget about shallow water equations. Now we're looking at a vertical problem, a problem in the vertical, a one-dimensional problem in the vertical. So what happens in the ocean is if wind stress along the surface, say on a time scale of several days, you get an acceleration near the surface, the Coriolis force kicks in, you have vertical friction between the individual layers in the ocean, and what happens is that there's an Ekman layer formed. The typical thickness of these Ekman layers is about 50 meters or so in the oceans, and you get a quite interesting structure within these Ekman. So this is what we're talking about now. We want to simulate the surface Ekman layer. So now how do we do this? Okay, now what type of forces do we need to consider? So we're looking at horizontal currents. Okay, horizontal currents are U and V. We had that before. We have the Coriolis force, and traditionally the Coriolis force is written on the left side of it. It's a little bit, you have to get used to it, but that's how it appears here. Okay, this is the Coriolis force, and on the other hand, we need vertical friction or vertical diffusion of momentum, and this is how it looks like, the vertical momentum. And you already saw horizontal momentum diffusion. That's quite similar form. There's no water depth in here or stuff like this. And there is this AZ is the viscosity, the turbulent viscosity, a parameter that determines how strong is the effect of vertical. Again, you can see that you have in each equation here. So now you also have to consider boundary conditions. Boundary conditions at the surface, you actually have the forcing by the wind, and the way to formulate that is because if wind stress creates a stress near the surface, there are these conditions here, boundary conditions. Okay, these are the boundary conditions, and you also have a zero gradient condition across the seabed, no friction across the seabed. And you can again formulate the wind stress in terms of wind speed component. This is just a little detail. You don't need the wind speed if you don't want to. You can just force it directly from the wind stress, which is units of Pascal. Okay, so this is the surface, and these ones are the equations that govern the surface Ekman layer. And you notice that we just ignored other things like pressure gradients. So because with these equations, which are always different versions of the so-called Navier-Stokes equations of fluid motion, we can play around and we can consider different aspects. Okay, and this is about this surface Ekman layer